All right, guys, this is a quick lesson on atomic structure. And then in a couple of days, I'm going to post another lesson on Bohr-Rutherford diagrams. So this one's just quick. You can get it all done today. It's not a big deal. All right. So atoms are made up of three subatomic particles. There are protons in the nucleus, electrons floating around the nucleus, and then the other particle inside the nucleus are called neutrons. All right, so protons are in the nucleus. They are positively charged. Neutrons also found in the nucleus, but they are neutral in charge. Possible charges, of course, are neutral, positive and negative. We've already gone through electricity, so you get the idea. And then finally, on the outside of the atom, we have negatively charged electrons. So that's basically it. That's the atomic structure. So if you take the simplest atom, the hydrogen atom, it's got a positively charged nucleus, and it's got a negative charge firing on the outside, one electron. So it's got one electron, one proton, and that's a hydrogen atom. Let's see what atomic number and atomic mass mean. So these can be found on the periodic table. The atomic number tells you the number of protons in the nucleus. And in your periodic table, I'll try and get a picture of it up here in a bit, but it should be in the top left of each cell. Each cell meaning each little part of the periodic table. The elements on the periodic table are arranged according to increasing atomic numbers if you go across the periods. Atomic mass, or the mass number, is the number of protons and neutrons combined in the atom's nucleus. For example, chlorine has an atomic number 17. That means that's the number of protons in the nucleus. It's also equal to the number of electrons flying around the outside of the nucleus. The mass number, though, or the atomic mass, is 35. And remember, it is the number of protons and neutrons. It sounds complicated to hear it for the first time, but it's actually not very difficult at all. We already know, since the atomic number is 17, that there's 17 protons. So how many neutrons does that mean there is? Well, if it's got to add up to 35, because that's the protons and the neutrons together, then it's got to be 18. And somebody can jump in on the comments and correct my math if I did it wrong. So atomic number tells me the protons and the electrons. The mass number tells me the number of protons and neutrons combined. So when we subtract these two guys, we should be able to figure out how many neutrons are in the nucleus. And that's what we're going to go through right here. Step one, the protons and electrons come from the atomic number. Done. Cl, it's element number 17. That means 17 protons, 17 electrons. Step two, to calculate the number of neutrons, take that mass number and subtract the atomic number, or the number of protons, and it tells you the number of neutrons. Which, did I get it right? Yep, 18 neutrons. All right, perfect. We're moving pretty fast here, so I can get this video uploaded. But pause this if you need to write anything down. So for arsenic, how many electrons? 33. How many protons? 33. How many neutrons? Well, I got to go 75 minus 33. I'm going to do that on my calculator right now. There it is. So I go 75 minus 33, and it makes 42 neutrons. And I got that again by going 75 minus 33. Potassium, element number 19. That means it's got 19 electrons. It's got 19 protons, and it's got 20 neutrons. I didn't use my calculator for that one, so you might want to check my math. And Au, I think, is the symbol for gold. Somebody can correct me if I'm wrong. Atomic number 79, that means there are 79 electrons, 79 protons, and how many neutrons? I can't do that in my head. 197 minus 79, it gives me 118. neutrons, 118. And as far as this first part of the lesson on atoms goes, that's about as tough as it gets, guys. Your assignment basically does all that. Oh, look, I got the answers here. That's fun. Did I get 42? What is it? 42, 20, and 118. Let's see. 42, 20, 118. Look at that. I can do math. Perfect. Now, just the definition of an isotope. So that mass number, again, it tells you, it lets you figure out how many neutrons are in the nucleus. But an isotope is an atom with the same number of protons. So because oxygen's got to have its, I think it's number 16, it's got to have its 16 protons. Protons defines the element that it is. So oxygen cannot have any different number of protons than its regular 16. But it can have a different number of neutrons and still exist as oxygen. And for oxygen, there are these different stable isotopes that happen to have different numbers of neutrons. The most common one, which makes up 99.76% of oxygen atoms, so most of them, have the atomic number, or the mass number rather, of 16 because it's 15.99. A really tiny percentage for these other two where they have one extra or two extra neutrons in the nucleus, which are also considered stable isotopes. All right, so that's what an isotope is. Same number of protons, but a different mass number because it's a different number of neutrons. Carbon can exist with a mass number of 12, 13, or 14. Oxygen can be 16, 17, or 18. Lithium can be 6 or 7. And there's lots of examples of these right across the periodic table, okay? The mass number that you see on the periodic table refers to the most common isotope. That's why oxygen, I don't have a periodic table in front of me, but I'm assuming that oxygen is element number 8, and its mass number is likely listed as 16, right? And that's because it normally has 8 protons and 8 neutrons in the nucleus. 99.76% of the time, that's how it exists. But there are other isotopes that can exist. That's what an isotope is, guys. So I have a short assignment to go with this one. Let me just get to it real quick if I can. Yeah, here's our course here. So as you'll see, I have all of your work for the week, this week, in one post. So we've got this very short lesson on atoms, and then the second lesson is on Bohr-Rutherford diagrams. And you guys can get it all done today and tomorrow. The way I think I have it planned out is so that you do this first part today and tomorrow, and then Thursday, Friday, the Bohr-Rutherford diagrams. But to go with this lesson, all I need you to do is fill out this Google Doc right here on Inside the Atom, in which you refer to page 234, 235, and the periodic table in the back of your book to fill out these things on subatomic particles, first of all, which this lesson we covered the names, the type of charge, and the location. Location, I'm just talking about inside the nucleus or outside the nucleus. Okay, so 2 of them are inside the nucleus, 1 of them's outside. It does tell you the relative masses. Now that's going to be something that's going to be in the section, so you'll have to look at that. Well, one of the particles is a lot lighter than the other 2, and 2 of them are almost equal. And then the final, well, not the final part, the next part, just look up its atomic number, number of protons, number of electrons. That should be very easy since hydrogen is atomic number 1. The number of protons in the nucleus then is 1, and the number of electrons around the nucleus is also 1. So you should see that by the time you're done that first table, it should seem really repetitive and even boring. If it seems boring, then you got it. You got it right on. Now, this part will be a little more challenging, but not much. So, for example, for carbon, chemical symbol C, atomic number 6, atomic mass 12, number of protons, number of neutrons, number of electrons. Now, the protons, neutrons, and electrons shouldn't always be equal. It is for carbon because the mass number is 12, so that's 6 protons, 6 neutrons. But for example, aluminum here, it's 13 and 27. So it's not going to be 13, 13, 13 across the board. Fill that out as accurately as you can. And then this last little bit is on isotopes, okay? And I'll let you guys figure that out. And that's the whole document that you need to fill out for the first half of this week's work. If you get that done, you get it submitted, you have half of your work for the week done. That's all I'm going to say about that in this video. I'm going to make a separate video for the other part. So get that done Tuesday, Wednesday, and then second half of the week, do the other stuff. It's supposed to be nicer the later we go into the week. So the sooner you get this done and handed in, then the sooner you can get outside and enjoy some fresh air. All right, that's all for now. Good luck, guys.